All right, guys, today we're doing section 2.2, which is trig functions of non-acute angles, aka lots of obtuse angles. And we have a really important vocab word this right away. It's called a reference angle, and it is the angle formed by the terminal side of an angle. So important word here, you remember what the word terminal means, and the x-axis. So basically you're going to draw all these angles like we've been drawing them, and then you have to figure out the reference angle. If you zoom in on this picture here, the reference angle is right here. And it has a symbol, theta, with a little apostrophe after it. It's referred to as theta prime. So we have our original angle here, and then remember this is the terminal side. So therefore the reference angle is formed by the terminal side and the x-axis. So over here in quadrant 2, our theta prime is right there. So same thing here, we have a big angle on this one, and the regular way that we know how to graph the angle starts at 0 and goes around. The theta prime is between the terminal side and the x-axis, so that's in red right here. So we're going to first figure out how to find all these reference angles, then we're going to use them to help us use the unit circle for a lot of these problems. Okay, so very first example, 218 degrees. So what does that look like? It's going to be in quadrant, what would that be, 3. So I'm going to draw quadrant 3. 218 degrees looks something like that. But my theta prime, what I'm looking for here, my reference angle, what is that? And so 218 degrees all the way around is past 180, but I want to know how different it is from 180. So you're doing 218 minus 180, and that gives you 38 degrees. So that's the reference angle. So therefore, if I were making a triangle out of this, I would know that that angle there is not in fact 218 degrees, but this right here is 38. Okay, let's try another one, 1387. So first of all, what we have to do is continue subtracting 360 to figure out how, like, where that actually is in my coordinates. So that's the same thing as 307. Remember, you just keep subtracting 360. I'm not going to spend time showing that. But where's 307 degrees? That's in quadrant 4. So I'm going to draw quadrant 4. 307 degrees looks like this. And if I were to make a triangle out of it, remember that we're always drawing our reference angle between the terminal side of the angle and the x-axis. So my theta is going to go here this time, theta prime. So how far away is that from the x-axis? Well, going around the circle here, the next x-axis number is 360 degrees. So how far is 307 from 360? So I'm doing 360 minus 307 gives me 53 degrees, goes here. Okay, another one that we have. So this is a negative angle. And so think to yourself, if I was drawing that, what quadrant would it be in? If you're negative, that means you're going this way, negative 124 degrees. But again, I want to know how far away it would be from 180. So the x-axis goes all the way to 180 degrees, but the terminal side stops here at 124. So 180 minus 124 gives us our theta prime for this one. And that gives you 56 degrees. So basically using some common sense about 180, 360 to figure out where the reference angle is, basically what angle goes in that triangle. All right, so now let's see what kinds of problems we'll be asked to do involving this new word reference angle. So find all the trig functions for 210 degrees. So I want you to first figure out what the reference angle for 210 is. So if I were to draw 210 degrees, I know that would put me in quadrant 3. So I'm going to draw a sketch here of quadrant 3. And I'm going to draw my triangle, trying to figure out what this angle is right here. So what's the difference between 180 degrees, because that's the x-axis in that direction, and 210? 210 minus 180, that gives me 30 here. Oh my gosh, you guys, we have a special triangle. Do you remember the side lengths that you memorized? Remember the radius or the hypotenuse is always 1. Which side is the short side here? We have a 30-degree angle right there, which means this is your short side. Even if you didn't draw it to look like the short side, that's okay. I know this is 1/2, and because it's in the third quadrant, I know I went down 1/2 units, so make sure you have your negative sign. That part is easily forgotten. And remember what the long side is? Radical 3/2. Remember, we use the same 3 sides for all the 30, 60, 90 triangles. And again, because we went left, this is X, this is third quadrant, again, we have a negative sign. Now we have all 3 of our sides, and we can fill in the trig functions. So here they are, you guys. Remember that the sine is the y value over the r value. The cosine is the x value over the r value. And the good news about the unit circle is when you divide by 1, it doesn't do anything. So for sine and cosine, and also cosecant and secant, you're really just looking at the x or the y value. For tangent, that's a little bit trickier. Remember, what you're doing is you're taking the y value divided by the x value. So let me just write down, just to refresh your memory, how we did that. The y value is -1/2. The x value is negative radical 3/2. Remember that you keep the original, or the numerator, excuse me, and you flip the denominator and multiply. 2's cancel, also negatives cancel, and we get 1 over rad 3, which rationalizes to radical 3/3. That is where that number came from, okay? So those are the 6 trig functions for 210 degrees. Let's do another one just to make sure we're okay. The exact value of cosine of -240 degrees. So again, what I'm going to do is graph -240 degrees. Now be careful because it's a negative. So that means when you do your axis, you're moving clockwise. And so can you think about what quadrant that's going to put you in? -240 is going to actually be in the second quadrant. So I'm going to draw a pic of quadrant 2, like so. And remember, -240 starts here and goes that way, -240 degrees. So I'm going to draw my triangle. I'm getting a little wobbly there. And let's figure out what the reference angle is. How far past 180 did I go to get to 240? That reference angle, you guys, is 60 degrees. Oh my gosh, it's another 30, 60, 90. Do you think you can plug in your side lengths again? Remember, the radius is always 1. The short side is 1/2. The short side is always across from the 30-degree angle, so this is my short side. Even if you didn't draw the picture very well, that's okay. And remember, I went left. This is in quadrant 2, so the x value is negative. And the long side is radical 3/2. So now we could do all 6 of the trig functions if we wanted to or needed to, but pay close attention here. This one only wanted the cosine. So remember how the cosine of theta is x over r, and the x value is -1/2, the r is 1. That is your answer for that one. All right, we just got 1 left for this video, and I want to do save the last 2 for class. The exact value of this one is tangent, okay, and 675. So first of all, we need to figure out what the coterminal angle is for that. So I'm going to subtract 360 real quick to figure out how to draw it. That gives me 315. Okay, so that means I'm in quadrant 315 degrees. That's almost to 360, so quadrant 4. So what I'm going to do here is draw my pic in quadrant 4. There is 315 degrees. Figure out what that reference angle is. How far away from 360 is it? 315, 360, that is a difference of 45 degrees. That's my reference angle. Oh my gosh, and we have our first 45, 45, 90 triangle. So remember, this is isosceles, because if that's 45 and we have a 90-degree angle, this one has to also be 45 because they got to add up to 180. Remember, the hypotenuse or the radius is always 1. Do you remember the side lengths? They are both radical 2/2. This one is negative. Don't lose that negative sign. This one is positive radical 2/2. Okay, and it wanted the tangent. So remember, the tangent is, I'm going to write it, y over x. In this case, my y value is negative rad 2/2. My x value is positive rad 2/2. You don't have to write it all out. You should know that it's -1, but whenever you divide a fraction or divide a number by itself, they just cancel. So we get -1. Okay, that is that. Like I said, I want to pause there and I want to finish these last two problems together in class tomorrow and answer whatever questions you might have. So good job using the unit circle. We'll see you tomorrow.